Hello, thanks for watching this video. Today what I'll be discussing is what is chemistry? Now we know the textbook definition of chemistry, the study of matter and its changes. We discussed earlier that matter is anything that can be touched or seen, and that means that we can talk about chemistry in lots of contexts as it applies to many things. I'm going to define that word chemistry a little bit different for you, just where I put the emphasis on the word. So if we say the word chemistry, then it sounds like it's all a big mystery that we don't understand. And for some it may be, but it might be that chemistry helps us solve a mystery or figure some things out. We could also say chem is try. You need to try if you want to be successful in chemistry. So if you try, that's the first step to be successful. Chemistry. I need you to try to master much of the material, because in chemistry everything will build on top of one another, and so it's not enough to only know 70% of each unit. We need to have closer to mastery on each unit so that we can be more successful. Now for some people, sadly, the class becomes chemistry, and it's just a nightmare for them. And that's not what I want it to be for you. I would prefer it's chemistry or chemistry or chemistry. Now, if somebody says, oh, you're a chemist, what kind of chemist are you? Well, there's lots of different types of chemists. It's sort of like if you're at a party, and adult parties are a little bit different than maybe parties at your age, and one of the questions people will ask is, so what job do you do? And I'll usually say, I'm a teacher, and I can see at that point they're not very impressed, like, oh, a teacher, oh, you couldn't do anything, so you were teaching. And then they always ask me the second question, it's the same one every time, what do you teach? And I always give them the same answer, students. And that throws them for a loop, like, oh yeah, I guess you do teach students. Then they say, what subject do you teach? And I say, chemistry. And I usually get a similar reaction, like, ooh, they're impressed, like, oh, you actually have a job skill and could earn money outside of teaching, right? And so, yeah, I'm a chemist, and my profession is as a teacher. Now, if you're a professional athlete, the second question might be, well, what sport do you play? And then what position do you play, right? And things such as that. And so the areas of chemistry that people generally study are listed here. And I will want you to be familiar with those different areas. So oftentimes people will be an organic chemist. They study things that contain the element carbon. Inorganic study everything else that does not contain carbon. Then there's specialty ones, like analytical chemists measure things carefully. Physical chemists study the properties and relationships between energy and matter, and biochemistry study the chemistry of living organisms. So I'm a biochemist by training, that's what my master's is in. I would say probably a third of chemists are organic. That's a very large area. Now there are sub-disciplines within here. People can go into chemical sales, chemical manufacturing, research, and so on, but these are the big areas. So I'm going to summarize them for you here. Organic, study carbon-containing compounds. Carbon is ubiquitous, it's all around us, and so that's a big area of chemistry. Inorganic is everything by definition that is not organic. So oftentimes things that are metals, and most of the elements on the periodic table are metals. Physical chemists measure physical properties of substances, melting point, adhesion, things like that. Now, we don't need a lot of physical chemists. I guess what could I use as an example? Maybe a school psychologist. If you have one school psychologist for a school of 1,000 students, that's probably enough. But if you have only one math teacher in a school of 1,000, that's probably not enough. So physical chemists are necessary, but we don't need a lot of them, because once these properties are measured, they're the same for everyone else to use. And then the biochemists, folks, these are the ones that do and study the chemistry in living things. So make sure you're familiar with those 4 different areas of chemistry, please. Stereotypes of chemists, right? We all have stereotypes, right? If I go do an outreach program to like Cub Scouts or Girl Scouts, if they're real little, one of the first things I do is I give them a sheet of paper and some crayons or pens and say, draw what a scientist looks like. And almost always the scientist is a male, wearing a white lab jacket, crazy hair, holding colored beakers, right? That's the stereotype of a chemist. I'll put down here, male, middle-aged, white, lab coat, kind of a nerd, maybe a geek, right? Now, I won't disagree. I might fit that particular stereotype, right? I'm a male, middle-aged, white. I wear a lab coat once in a while. I'm a little bit nerdy. But there's also really cool chemists as well, right? Like if I think of an accountant, I think of somebody, working in a little cubicle with sharp little pencils, writing stuff very meticulously. And yet I know there are some very attractive accountants out there as well, right? A job doesn't specify one narrow range. We want chemists to be as creative as well as meticulous and everything in between, right? And so a better view of a chemist might be somebody like MacGyver, right? It was a TV show back in the 80s and 90s where MacGyver might be caught in a Chinese prison and he pulls a ballpoint pen from his pocket, takes out a piece of gum and scrapes something from the wall and blows the doors off the jail that he's in, right? That's what chemists do. They take the natural materials around them, they analyze the situation, and they solve a problem, right? That's a much better view of a chemist than this nerdy looking view here. So what can you do with a chemistry degree? Well, lots and lots of things. You can do research. That's what a lot of people think of. They discover and make new products. You can do production, where you're the actual manufacturer of those discovered things, and you're doing quality control, or you're scaling up the processing plant, you're a chemical engineer. You can be the technical salesperson, selling chemicals to different businesses or to different consumers. Chemical sales is huge. It might be to the pharmaceutical industry. You can be a software engineer because they need computer engineering that have the special skills and understanding of the chemistry to do the programming. You could go into teaching. You see, there's a lot of different things you can do with a chemistry degree. We've had numerous politicians with chemistry degrees. I think the present Chancellor of Germany has a PhD in physical chemistry. The Iron Maiden, Margaret Thatcher, the Prime Minister of England, had, I believe, a PhD in chemistry as well. We've had a couple of our governors that have had chemistry degrees. Now, they didn't use their chemistry in their job as a politician, but instead they used the training, the analytical thought processes that it developed in their jobs. Some people on Wall Street that are highly successful, different analysts, had backgrounds in chemistry because they're used to looking at trends and finding patterns and data. And so you can do quite a bit with a chemistry degree. All right, so I've listed them here again for you just to kind of review. You can be a researcher, work in production, work in development, work in chemical sales, software engineering, teaching, pharmacist, lots of things you can do with a chemistry degree. Okay. When studying chemistry, though, the skills that it develops can be applied to most areas of your life. So even if you never pursue a career related to chemistry, this course is not a waste of your time. So I've defined here chemistry for you, the study of matter and its changes. We discussed the different areas of chemistry. I'll list them there for you one more time. You can read them quickly. And I know we've already talked about the government regulation. I'm just sort of reviewing that for you. It's been a few days since we've touched on that. Remember, I said we need the government to sort of keep us safe. So we have things like the EPA for the environment, to protect the environment from people and companies dumping chemicals. For the consumer, we have the Consumer Product Safety Commission, United States Department of Agriculture, the Food and Drug Administration. For the worker, we have the Occupational Safety and Health Administration. All of these are there to protect us from the dangers, the potential dangers of chemicals. Now, chemicals are not inherently evil. They're not inherently good. How we use them, how we store them, that determines if they are good or bad. These are some, again, just areas, things you could do with chemistry. I'm not going to read all those for you. I just want to kind of let you know that this course, you can actually become a career if you pursue chemistry. All right, that's about as far as I wanted to get today. I guess maybe I'll just mention this last little slide, and then we'll probably stop here. Petroleum products was a huge area of the chemical industry, and petroleum would be talking about crude oil. From crude oil, we can make lots of things. We make gasoline for automobiles, and oil, and diesel fuel, and heating oil, and jet fuel. All of these come from crude oil, as well as things like nylon that makes your football jersey and many of your clothes. Those would all be synthetic or man-made petroleum-based products. There are some synthetic fibers that chemists make: nylon, polyester, rayon. There's one of my favorites, spandex. Now, if you rearrange the letters of spandex, it spells out E-X-P-A-N-D-S, expands, right? You can't call a material that is really stretchy expands, because you're probably not selling it to super fit individuals. So instead you call it spandex, and it sounds more special. Pharmaceutical is a large area of the chemical industry. These are the medicines that you might take for cancer or other problems that you might have. It turns out that when you manufacture drugs and medicine, the process of going through the FDA regulation is very challenging, very difficult. It turns out that for every 10,000 potential new products, only one of them, 1 out of 10,000, receives FDA approval. So that's sometimes the reasons why medications are so expensive, because you have to pay for the research of making 10,000 items, even though only one of them is of any value. So you're not paying the cost of the manufacture, you're paying the cost of the research and development of that particular medicine that you're taking. There's also bulk chemical manufacturing. These are the people that make the raw materials, like maybe you bake your own bread, and you have to buy your own yeast, buy your own flour, and everything else, right? About a month ago, President Trump called Kodak Company an essential company to make raw chemicals, so we did not have to rely on other countries to make the chemicals that then make the drugs that we need. And we did not have that in the pipeline, so Kodak was given a huge amount of money to do that. There's a little bit of controversy related to that, related to some insider trading, and I think they've since maybe told Kodak, hold off on that, we might pick a different company. And it changed their stock price from just a couple dollars up to like $20 in a couple days, and now it's back down to like $6 or $7 again, because they haven't decided if they'll be able to keep that contract. The number one chemical in the world is sulfuric acid. It's a common acid used in the manufacture of many, many, many things. If you were to look at the gross national product of a country versus the amount of sulfuric acid they use, they would mirror each other almost exactly. If a country does manufacturing, they use sulfuric acid. So the bottom line is, most fields, most jobs are affected by the chemical industry. All right, that one we went through. I'm not going through that stuff. We will look at maybe other little areas where it could relate. One of you, I forget who it was, maybe a couple people told me they want to do forensic science, right? So oftentimes you have to have a little background. It turns out if there's a fire, they can tell where the fire started because it's the highest temperature. and metals have different melting points. So if copper melts, it has to be a certain height, a certain temperature. That's different if aluminum melts. Aluminum would have a lower melting point temperature. So they can determine where a fire started, if their accelerant was used. Lots and lots of stuff you can do with forensic science, knowing some basic chemistry. All right, I'm skipping through that. This is the last slide I'll share with you. This is a very old set of data. Look at the year, 1998, right? I know you weren't even born yet. But it has the starting salaries of a bachelor chemist, $45,000, versus a master's versus a PhD. And then you can kind of see, I didn't put the communications degree down there, but a bachelor's in communication in 1998 probably would have made about $25,000. And so a bachelor's in chemistry would have made $45,000. Well, that's a pretty substantial difference. So when you go to college, all majors are not alike. Some are going to be more challenging, and the reward will be you'll be paid more when you go to work. I put down here some physicians' salaries back in 1998 for a resident. You would have made not a lot of money, but it was enough, at least you weren't paying for school anymore, and so it was enough that you could get by. And then earnings for physicians, 120 to 240,000. You can easily double that number nowadays for the earnings of a physician. Salaries for chemists haven't gone up that much. A bachelor's might get you about 50,000 now. So it hasn't really changed a lot for 25 years. Just wanted to give you a few details. Thanks for listening. Have a great day. Bye-bye.